Hello. Last day we have finished with the introduction of domain of functions and we have done some of the problems, right? Not many problems we did, but very less number of problems. But remember, those problems are very powerful, even if smaller. Now today we are going to start with first algebra of functions and then we'll talk about range, which is very important part. Literally today we'll be finishing with the theory part of the functions of class 11 and then we'll be taking the problems. Maybe one more classes, one more video will be enough for finishing the rest of the parts. If we confine up to the NCERT syllabus. So let's start. We are going to start with algebra of functions. Algebra of functions. So what is algebra of functions? Just you see, we will consider two real functions we will consider, right? These are real functions, or rather let me not consider the domain as R. Let the codomain be R. Say this be domain 1 and another function say F2. This is F1. It is F2. Domain is D2. So these two are real functions. We have considered real functions. So in that case, if suppose I would like to add them, right? Addition, if I do F1 plus F2, this will be also a function, right? A real function. Now, from which domain? That's a very important thing. And how we do it? What is the working rule for it? So working rule is that F1 plus F2x is equal to F1x plus F2x, right? And as these two both should be valid, so we have to pick x from a particular part. From where it should be from D1 intersection D2. That means those x only will consider as a domain of F1 plus F2 where both the functions are defined, right? So it should be the intersection of D1 and D2. Now this is going to happen true for all the remaining operations, right? So I might not write the rest of the parts like this. So number 2, if I do the same thing for difference, right? If I do the same thing for difference also is done like this, right? Domain remains the same, intersection. Now I can do this even for the product of functions. If F1, F2 I take, then this is F1x and F2x, where still the domain is D1 intersection D2. And then if I do it for F1 by F2, that is division of functions, quotient of functions rather, then I can still get this, right? But here there is a small exception. What is that exceptions? I have to exclude all those value of x for which f2x is 0, right? That I have to exempt, not accept. So first of all, x belongs to D1 intersection D2 and those values where f2x is not equal to 0, right? Because all of you know, if it will be becoming 0, what will happen? You will not be able to define this, right? So these are the algebra of functions. One more thing is there, that is okay, let me write only. Why to leave that? See, if there is a constant multiplied to a function, then constant will be always out, right? It can be always taken out of the function. It can be taken common rather from the terms which are there. So this is a very simple thing. We'll be taking up the problems of this, not at this moment. Now let me talk about the range, which is very important part of function, right? So let's move on to the range. So before working any problems, just again I would like to tell you what is actually the range, right? I'll first show you a model as I told you, right, earlier. So, and then we'll talk about the problems and how to proceed, how to tackle the problems of range. Remember, in comparison to domain, the problem of range, right, the problem of range may not be such comfortable, but anyway, I should not say that it is difficult, right? If I say difficult, it will be wrong in my part, right? So I'll not say that these are difficult. Just let us see what we'll get. Yes, this time I'm holding in front of you, right? Some lighting is there. Anyway, now you can see two domains. I did not mention one domain and another codomain for the function. I did not mention a, b, neither I told the function as f or g or whatsoever. So these are the points whose images are marked here, right, by the arrowheads, right? So now this side it was the domain, this side it was the codomain, and range is the exclusive set where the elements of this side codomain must be taken which are related to whom? Some of the elements of this side, sides. Okay, so now let us see, is there any element which is not having any pre-image? No. That means this entire yellow set here, all these is going to form the range, right? Now just you see, I want to remove one point from here, and then I would like to consider this function, right? I would like to consider this function. Now you consider this function and see here what is the range. What is the range here? You see there is a point here, all the elements are related, that is the dividend of the function, but here there may be some points which are not having pre-images. So in this particular case, range will be consisting of what? 1, 2, 4, 5, 6, 7, 8 and 9, but this 3 will not be there, unlike to the previous case, right? So got it? So now this is the idea which we'll take forward, but thing is that when we do it actually, we may not be observing it so well, right? So we have to apply our basic logic. So let's start with easy problems first. We will not do much more bigger things, but before that I'll draw a figure so that you can see, if this is a domain and this is the codomain, and there is a function, that is a rule which relates elements of A to B. Now remember, I told you about a machine. This is the machine, this is the inputs, here are the outputs. Whatever are the outputs, they are known as the elements in the range, right? So if you give a input x, the output is fx under this fx. So whatever is the output here, you write that in the set form, that is the range, right? To be very easy concept, right? So now if I define formally range of f, how do we define that? Also you must know. Range of f is what? It is consisting of what? All those fx, right, for all x belongs to domain. Whatever x you take from A, whatever is the output coming, give or put them in a set, then that set is known as the range, right? And range is always a part of the codomain. Already you have seen, sometimes whole codomain might come as a range, or else some elements will be left out, but no extra elements will come. So it is always a subset of codomain. Range of a function is always a subset of codomain. A very important part. Subset, why? Because sometimes it may be equal also. Now let's go for some of the easy problems, right? After that only we will be taking little difficult problem. First let us warm up, right? Okay, so that we understand the basic of the functions. Now I'll be taking some functions, real functions only, but not with continuous domain. Like I'll take discrete domain. Discrete means individualized points are there, so that we can understand it easily. Say there is a function from natural number to natural number such that, right, such that f of x is written as x square plus 1, right? F of x is written as x square plus 1, right? Let me try to restrict, otherwise this will be a very bigger set. So let me restrict that to make it easier at the beginning, right? So let me write this as a, where a consists of 1, 2, 3 up to 9, and this is the function. Now you have to find the range. This is a domain, already it is very clear. So let us see first in the figure. We'll be explaining all theoretical problems in the next videos. First, now make the basic clear. This is the set A, this is n. I have the function defined like this. My inputs are what? 1, 2, 3, 4, 5, 6, 7, 8, 9. These are my inputs, x, right? This I have to put in the machine, what I show you earlier. And now whatever is coming out as the product, I have to keep it here, right? And that I have to tell as a range, right? With that, many other things may be coming. Coming means here it will not be coming, but the natural number is there. So except those which are coming out from this, something more may be there that I need not take for finding the range, right? So just following these particular rules, you find 1 will be related to whom? 1 square plus 1, 2. 2 will be related to 5. 3 will be related to 10. 4 will be related to 17. How did I get it so quickly? You can also get. If I put 4 here, 4 square plus 1, 17, right? That means 4, if I give the input as 4, F4 is the output, right? And this value is 17. Is that very clear to you? So now this 5, 25 plus 1, that is 26, 37, and then 50, 65, and 82. Now there are many other natural numbers which are not related to any of the elements here. Just say 1, 3, 4, then 6, 7. These will be there. I will not write all. These will be there. So now from here, if I ask you what is the range, domain is very clear in the left side set, right? So your range will be what? What will be your range? Range is simply containing, this is 2, 5, 10, these elements you have to write, right? These are the elements which are in the range. And if codomain I ask you, the whole entire natural number set in the right hand side. So this is the range. Now this is a very easy problem where we can give the input and we can find. This is easy because, try to understand, this is easy because this is a discrete problem. The set is a discrete one. Discrete means individual points, no continuous points. If it will be intervals, had the domain been a real numbers set, right, or a continuous dense set of real number, then but dense is a very higher concept, forget about that. As a real number set other than this, natural numbers, integers, or I'm talking about decimal numbers, right? So it would have been difficult for us to find so quickly all this, right? So basic idea is to find a range is what? Whatever is the input, apart from, if you go on giving those inputs, whatever are the outputs coming out, what type of character it process, that's you have to take, right? And once you'll be able to explain this, then you are getting the range very clearly, right? So I don't know whether I am able to make you clear or not. So I'll be taking now few small problems so that you'll be able to understand, right? Afterwards we'll take the bigger problems. Now I'll be going with the theoretical approach little so that we can see the process how to work. So there is a function f of f such that it is from R to R, right? Rather I'll write R star to R star, where I write R star means all real number except 0 such that fx equal to 1 by x. Or I'll make it little easier. Let's make it little easier, right? Let's make it easier, then it will be easy for us to understand. Let us not make it R star, let us make it n natural number. And my question is this: f of x equal to 1 by x, and then I have to find the range. Domain is very clear, natural number. Now you have to find the range. So give a quick look what type of numbers you are going to get here. Now I am doing it very roughly for explanation purpose. So just see this. My input is x, output is reciprocal of that. 1 by x, reciprocal. You just make it upside down. If I give 1 as the input, output will be 1 by 1, that is 1 only. If I give 2, coming out as half. If I give 3, coming out as 3, 1 by 3, 4, 1 by 4, 5, 1 by 5, and so on. And so on. Now, can you just observe a character? What type of output you are going to get once you give the input 1, 2, 3, 4? You are getting the reciprocal. And as you are giving the input as the natural number, so reciprocal will be always containing 1 in the numerator and denominator the input, right? Am I clear to you? So it's a general case. If you give input 3, 1 by 3 will come out, right? So it's the number of the form 1, 1 by 2, 1 by 3, 1 by 4. So range will be what? So your range will be what? What will be the range of f? It will be 1, half, 1 by 3, 1 by 4, 1 by 5, like that you go on, right? And the codomain will be the right hand side set, whatever is there, that you just have to write like this. Now just you tell, can it be made little better to write? Okay, we'll be using it as 1 by n such that n belongs to natural number. This is much better to explain like this, right? So whatever natural number you take, it is 1 by n. This is the range. Anyway, as I told you, I have taken a very simple question so that you understand the concept, right? Now go back to the original question what I started with, right? What's the problem with that? Or you would like to go for another? Okay, there is a task for you. Change it to integer, do it yourself, see what is the range. Change it to whole number, just see whether it is valid or not. Let me try to tell you, if you directly replace it by whole number or integers, it will not be valid. You have to consider the domain as whole number. If you consider to gone, 0 if you exclude, it is already natural number, so it is not needed to be done. Integer, if you consider, you take non-zero integers. That means positive integers, negative integers, but 0 not there. And in that case, what will be the output? Just try to see that. I'm coming back to what I started with. I started with R star, right? I started with R star. Now, what happens to this? See, earlier we had been taking counting numbers 1, 2, 3, 4. We had the limitations. Now I am going to consider all real numbers which are other than 0. Now it's difficult for me to predict. If I give input 1 by 1, okay, fine. If I give a input as root 3, because non-zero real number can be root 3 also. If I give pi, 1 by pi, right? I can give 2 by 3, output is 3 by 2. So now how will you describe this? That's the real challenge, right? So here I'm going to start with a formal process of finding the range that you try to see. But before I start with, I'll show you what's my process of action, right? Just you see, my means it's the process of action for finding the codomain range for all the functions, right? So you try to see what exactly we are going to do for finding the range. This is what we are given. I have to find what is the range, what is the output set. So how do I proceed? Suppose this be the range. I do not know presently whether elements will be outside, some elements will be remaining or not. I don't know. I don't have any idea at all. So, but I consider that this is the range. So let us pick one element from the range. I'll pick one element from the range randomly. See, I'm picking it from the range, not from the codomain. Right? Because codomain can contain some elements which are not in the range of the function. In that case, it will not have pre-image. So I'm picking up precisely elements from the range so that I can get some pre-images for them. So if I pick y from the range, it is very sure that I am going to get some x here whose image will be y. I am very sure. So in that case, what I can write? I can write like this. Image of x is y. I can write. But see, till now I don't have any idea about y, because y I have chosen arbitrarily, means randomly, right? Now my task is to observe the whole things and talk about the character of y. What type of y I am getting? How will I talk about? Right? Now you see, because you are going to find a range, before that you must be clear about domain. You must be knowing the input, right? So you already have a good idea about the input, right? Whether it is real number, natural number, or irrational number, or whatsoever, right? So that means indirectly I'm trying to say that I know about x. I know about the character of x. This x I know. So what I do from this, using the definition of function, I'll express everything in y, and I'll find the expression for x in terms of some y, right? And then looking at this expression, I can comment on x, right? I can think on x, for what value of these things this is valid, right? And then that way we can express or talk about y, right? Now of course, if I do not write any expression, it will be a vague concept presently. I'm sure that you are not getting 100%, so let's try for it. So let's try for this, right? So I'm following the complete expressions what you need to write for actual problems. So I'll write let y belongs to range, right? Y belongs to range be arbitrary. Y belongs to range be arbitrary, right? Arbitrary means any randomly picked up point. Then there must exist, right? There must exist x belongs to domain, right? You may write r plus r star also, such that f of x equal to y. Till here I'm sure that you are very clear. Now what I said, once you arrive at this particular step, you have to apply the definition what is given here. So once I get fx, that can be replaced by 1 by x, y. Fine. Now next, you have to express x in terms of y. So now you write x, then this will be coming out as 1 by y. That's the very important part which you have to notice, and from here only your observation plays a very important role to comment on y. Now you think, what type of x you have started with? You have started with x, some real number which are not 0, right? 0 is not there, but it is a real number. Okay, very fine. If x is a real number, now you tell what can, right, what value of y can make x not a real number. Means if you put y equal to suppose 1, will x not be a real number? No, it is a real number. That means 1 can be there as a value of y. Okay, fine. 2 if I put, it will be a real number. Root 3 if I put, real number. Minus 4 if I put, real number. Because if I put minus 4, x will be minus 1 by 4. It is a real number. Is there any value for which it will not come out as real? Yes, there is one. What is that? 0 if you put. 1 by 0. That means only one value of y is there, which if you put here, it will not be a real number. It becomes undefined. That means y should be taking all those values. Y should be taking all those values except 0. All real numbers value except 0. Am I clear to you? It is very clear from here. One more thing, if you observe, already we mentioned that this is R star. 0 has been already excluded. So it means whatever value you want to pick from R star, that is right hand side, you pick, they will give you a real number. That means for all non-zero real number possibilities of y, this is possible. So y belongs to what? Non-zero real numbers set. So that is the range, right? So this is how we find. Now I am going to write, I am going to give the supporting statements so that you must know how to proceed further in order to score marks, in fact, the exams. So how will I write? This happens clearly. As x is non-zero real, therefore y must be non-zero real, right? That is, y belongs to r star minus 0, Now you see, again I would like to tell you, one more point is there which we have to always say. Here of course it will not harm. Once you find or observe the value of y from here, it's not the ultimate, because sometimes the original definition also contains something which are really ridiculous or really dangerous if you omit. So here we don't have, so I can write here, but what I have to see, I'm telling you. Once I arrive at this, then you go back to the original definition of the function. Fx equal to 1 by x, right? Fx means y, right? Isn't it? So here you see, y is having any specific notations, right? There is nothing, right? So of course right at this moment you may not be able to observe. When I take another problem, then you will be able to observe. So because of that, this itself will work as the range. So you write, therefore range of f is equal to r star, sorry, not r star minus 0, r minus 0, that is nothing but r star. So now your range is actually here, domain in the range of both same, right? So take a little time, make sure that you understand these things. I'm going to take more problems now only, so but you pause the video, try to see, and you might have observed I have gone very slowly, in fact, right? Okay, so now I'll be taking one more problem right? One more problem for range. One more problem for range, so that you'll be able to work with this particular type of cases. See, there is a function, right? There is a function defined from 1 to infinity till the real number, such that the function is f of x equal to under root x minus 1, under root x minus 1, square root of x minus 1, square root of x minus 1. You are already told the domain. Domain is already told. So now you have to find a range. I'm not writing these questions very formally because I'm just explaining it. I'll be taking much more problems. I have to find a range, right? First of all, as I told you, you have to create that environment what you did earlier. Environment is what? This is the map. I have to find y here, whose pre-image I know. Now I have to talk about the y. That's it, right? So now process remains the same. Let y belongs to range be arbitrary, right? Arbitrary. Then there exists some x belongs to domain such that what you can write, f of x equal to y. Then your next step is to write the function x minus 1 equal to y. What was the next step? You have to find what is x. So you will square it and then you write what is x. X will be what? It is y square plus 1. This is what's the very, very crucial point. Now you have to observe. What was x? Some number which is greater than 1. Some real number which is greater than 1. It should not be less than 1. Now just try to observe. Can there be any value of y? You have to check the real numbers. If I go on putting here, will it generate some number, right? Which we have to generate some, we have to see some numbers or possibilities of y. Will it generate x which is less than 1? Now for that, meticulously you observe. Y has a power 2. So if power square is there, power is 2, that means square, it will make every negative quantity, negative entry a positive one. Very nice. That is a good observation. So even if you input minus 1 for y, matlab if you consider y equal to minus 1, then also y square will be plus. Minus 2 if you consider, it will be plus 4. Means in no case this is going to be negative. What is the minimum possible value it can allow? 0. Y can be minimum 0. Fine. What does that mean? If this has minimum value 0, then also it will be equal to 1. That means x will be equal to 1. And it is allowed. Right? It will not be allowed if x I get which is less than 1. So now go on putting any value of y, you would check. It will be every time greater than 1. That means there is no such value of y which if you put here, you will get any x which is not in this interval. Right? That means for every value, every real value of y, you will be getting the real, this x, whatever is needed. So now we can write it like this. Clearly, for every y belongs to real number, y square is greater than or equal to 0. right? See, we have to change the style. What I explained, that also you can write directly, but I'm doing in a modified way. Now if I add 1 to both the sides, I'll be getting, now what does that mean? X greater than or equal to 1. And it is true, right? That means for every real number x greater than or equal to 1, I am getting. And that's what I need in the beginning. Domain contains only numbers greater than 1, greater than or equal to 1. That means that is y belongs to real number. So this tells you that y is in the real number. So now should I conclude from here that required range, because y is the element from the range, now I have observed the nature of y, what type of y I should get? Real number y. So therefore the range is y. Should I conclude like this? No, there is a point again I am telling you. In the last question it was not valid, but here it will be valid. What is the point you see? For that you have to come back to the original definition. What is the original definition? Because see, fx is equal to only y. This is y. That means y is nothing but root over x minus 1. What is the sign in front of this? Previous day I discussed. Root over whatever sign is given in front, that only is to be accepted. This is what sign? Positive. This is positive sign. If this is positive sign, what root you have to take? Positive values. If you want to take positive value, whose positive value you should take? Y is positive value. But if you say y is real number, are you taking only the positive? No. You are taking negative values as well. That is not allowed. That is not allowed. So here 0 will be included. 0 can be taken because 1 is there. But except 0, no other negative values. 0 is having no polarity, either positive or negative. 0 is allowed, but negative values are not allowed. So y you cannot take from the negative real numbers. So ultimately combining this and this, your answer will be what? All real numbers which are greater than or equal to 0. Right? That's the conclusion you have to now make. So how will you write this? See. But, right? From the definition. But y is non-negative. Non-negative means it can be 0, but cannot be negative. Do not write positive, right? Some people might write positive, galat. So therefore, combining this and this, y belongs to r, right? R plus union 0. R plus union 0. R plus means real number positive and then union 0. Now that's the range, right? All positive real numbers. So this is how you are going to work out for finding the range. So just check it. Will there be any mistake here? Just check it. If you identify any mistake, it will be a great privilege for me that you are able to identify that. Okay, so today with this problem I finish today's class. Then next whatever will be the class of videos, will be taking only the problems. Probably maximum 2 videos will be needing to finish with the problems of the book. Right? So till then, bye.